Hello viewers, in today's class we are going to discuss one important problem from indefinite integrals, right? And here we are given this integral, that is 2x minus 1 divided by x plus 1 times x square plus 2, right? So we'll solve this integral by method of partial fractions, right? So let us see how we can solve this integral by making use of partial fractions, right? So now let us first denote this integral by I, right? Now here we are given a rational function, right? So here we can denote this integrand by f of x, right? So f of x is given as 2x minus 1 divided by x plus 1 multiplied x square plus 2, right? So whenever we have an integrand which is of the form px over qx, where px and qx are polynomials, right? So when px and qx are polynomials, then such a function is known as rational function, right? And provided that q of x is obviously not equal to 0, right? So in such cases, when we have the numerator as a polynomial and denominator is also a polynomial, then we decompose this integrand in terms of partial fractions, right? So there are a lot of methods to decompose a rational function into partial fractions, right? And the method depends on the nature of a rational function, right? By nature we mean that the structure of the rational function. So now by structure of rational function we mean that, see here in the numerator we have a linear function, right? A linear polynomial is given, so in the numerator we have a linear polynomial, right? And in the denominator we have a linear polynomial, right? So we are writing it as linear, and then we have a quadratic polynomial, right? So when the nature of the rational function, which is here f of x, is linear over linear times quadratic, then we have to decompose this rational function into partial fractions by see here the method goes like this. We have a over a linear factor, right? And then we have bx plus c divided by the quadratic polynomial, right? So here we have written bx plus c because see here the quadratic polynomial x square plus 2 cannot be resolved into linear factors, right? Because x square plus 2 cannot be written as a product of two linear factors, right? So this is not factorizable. Hence, when we have a quadratic polynomial in the denominator, then we always have a term like bx plus c in the numerator, right? Suppose instead of x square plus 2, if we had a rational function like this, 2x minus 1 over x plus 1, and say we have x square minus 4, right? So in this case what we have done, or what we have to do, is 2x minus 1 over x plus 1, and will factorize this quadratic polynomial in terms of linear factors, right? And x square minus 4 can be written like this, and this is x minus 2 x plus 2, right? So in that case we would have x minus 2 and x plus 2, right? So initially when we look at this rational function, we see that the denominator is the product of linear factor and quadratic factor, right? And further the quadratic factor can be resolved in terms of linear factors, the two linear factors. So now the denominator consists of three linear factors, right? So if we write it as linear, linear and linear, then we can write it as L2, this is L3, right? So if we denote the linear factors in the denominator by L1, L2 and L3, then this rational function can be resolved like this: a over L1 plus b over L2 and c over L3, right? But in our given problem, we have a quadratic polynomial which cannot be resolved into linear factor, right? So whenever the quadratic polynomial is not resolved into linear factors, we had a term like bx plus c, right? So now this function f of x can be written like this. We can write it as a over x plus 1, right? Because this is the first linear factor, and then we have bx plus c divided by x square plus 2, right? So now we have these two partial fractions, right? So now let us simplify it. So if we take the LCM, we have x plus 1, here we have x square plus 2, and then we have a times x square plus 2 plus x plus 1 and bx plus c, right? Okay, and for f of x, here we have 2x minus 1 divided by x plus 1 and x square plus 2, right? So now these two terms get cancelled, or we can compare both the sides. So we have 2x minus 1 is equal to a times x square plus 2 plus x plus 1, and here we have bx plus c, right? So now our aim is to find out the value of a, b and c, right? So let us see how we can find out the values of a, b and c. So now let us write this expression like this. Here we have 2x minus 1. Here we can write ax square plus 2a, and c. Here we have two binomials. So if we multiply, then we get bx square plus cx, and then plus bx, and then we have c, right? So now we can arrange the terms, and here we have ax square, here we have bx square. So we have a plus b x square, and then the coefficient of x is c plus b, and here the constant terms are 2a and c, so we can write 2a and c together. So we have 2a plus c, right? And c, now here we have a quadratic expression, right? So the coefficient of x square is a plus b, coefficient of x is c plus b, and the constant term is 2a plus c, right? Now if we compare the coefficient of x square, x, and the constant term in both the sides, then see what we get, right? And here if we add a term like this, that is 0x square, then there is no harm in it, right? So now if we compare both these sides, then see a plus b is equal to 0, right? So we have a plus b is equal to 0, that is the coefficient of x square. We have equated the coefficient of x square on both sides. Similarly, c plus b is equal to 2, right? So c plus b is equal to 2, and the constant term is minus 1, right? So we have 2a plus c is equal to minus 1, right? So now here we have three variables a, b, c, and three equations, right? So now we can solve these three equations to get the value of a, b and c. So from this equation, we have a is equal to minus b, right? Okay, and from this equation, that is c plus b is equal to 2, here we can write the value of b as minus a. So we have c minus a is equal to 2, and here we have 2a plus c is equal to minus 1, right? So now let us solve these two equations. So if we subtract these two equations, then c and c get cancelled and we are left with minus a minus 2a, and here we have 2 minus minus 1, so this is minus 3a, and here we have 2 plus 1, that is 3. So the value of a is 3 over minus 3, that is minus 1. And if we take this value of a in this equation, then minus b is equal to minus 1, so b is equal to 1, right? And if we take this value of b in this equation, then we have c plus 1 is equal to 2, that is c is 2 minus 1, that is 1, so the value of c is 1, right? So now we have a is equal to minus 1, b is equal to 1, and c is equal to 1, right? So now let us substitute these values in this expression, right? So we have f of x is equal to a is minus 1, so we have minus 1 over x plus 1, and the value of b is 1, so we have 1x, and here c is 1, so we have plus 1 divided by x square plus 2, right? So this can be written as minus 1 over x plus 1, and this is x plus 1 over x square plus 2, right? Okay, so now this expression, which was assumed as f of x, so we have integral of f of x dx, right? So now I can be written as integral of this expression, that is minus 1 over x plus 1, then we have x plus 1 over x square plus 2, and here we have dx, right? So now we can easily integrate this expression, so we can now write I is equal to minus integral dx over x plus 1, that is this one, and then we have integral of x plus 1 over x square plus 2 dx, right? Okay, now the integral of this 1 over x plus 1 is log of x plus 1, right? And see, here we can split this integral as a sum of two integrals, so we can now write x over x square plus 2 dx plus 1 over x square plus 2 dx, right? So here we have x square, right? Okay, so now we have minus log x plus 1, and here see the derivative of x square plus 2 is 2x. So what we will do, here we'll take half and here we'll take 2, and we have 2x over x square plus 2 and dx, right? And here we have 1 over x square plus 2, and 2 can be written as square root of 2 square, right? So why we have done these two things here, we have taken 2 in the denominator and in the numerator, so the derivative of x square plus 2 is 2x. So now we have minus log x plus 1, and here we have half, and the integral of 2x over x square plus 2 is x square log of x square plus 2, and here we have 1 over x square plus root 2 square, and the integral is 1 over root 2 tan inverse x over root 2, right? And c is the constant of integration. So this is the final integral for this function, right? So now here let us quickly see the formulas or the results which we have used in these three integrals, right? So here we have used the result, that is integral of 1 over x plus a is log of x plus a, right? Okay, so here we have 1 over x plus 1, this is x plus a, so the integral is log of x plus 1. And here the derivative of x square plus 2 is 2x, so we have written the integral as log of x square plus 2. So we know that if we have a function in the denominator and the derivative exists in the numerator, then the integral is the log of this function, that is f of x, right? And in the third integral we have used the result, that is 1 over x square plus a square is 1 over a tan inverse x over a, right? So for a, here we have a is equal to square root of 2, right? So this is how, by method of partial fractions, or we can say by decomposing this integrand into partial fractions, we have obtained the desired integral.